In order to graph this function, we need to find the asymptotes. Since the degree in the denominator is larger than the degree in the numerator, there is no linear oblique asymptote and the horizontal asymptote is at y equals 0. Now we need to find the vertical asymptote. In order to do that, we need to factor the denominator. So, I have factored the denominator, showed my work on the side, and ended up with 2x minus 7 and x plus 3. If we set each bracket to 0, we get x is equal to 7 over 2 and x is equal to negative 3. These are our vertical asymptotes. Since these values here are what make the function equal 0, these values are also the restrictions, since the graph does not touch or cross these points. Now we move on to the end behaviors. We need to find values that are really close to the asymptote, sub them into our function, and get y values that will tell us which direction the graph is going. In order to get values that are very, very close to the asymptote is to take the asymptote and add 0.001 or subtract it. So in this first one, we have a vertical asymptote at 7 over 2, or in decimal form is 3.5. I've added 0.001, subbed it into the function, and got a very, very large value. This tells us that when our x value is somewhere about here, our y value is really, really high up. So this tells us that the graph goes in this direction. Now, I took my vertical asymptote and subtracted 0.001, got a value, subbed into my function, and got a very, very large negative number. This tells us that when our x value is somewhere about here, our y value is really, really far down into the negative numbers. This tells us that the graph is going somewhere in this direction. I did exactly the same thing for when the asymptote is at negative 3. I added 0.001, got this value, and subbed it into my function, and got a value that is a very, very large positive number. So that tells us when our x value is somewhere about here, our y value is really high up here. So this tells us the graph goes in this direction. When I subtracted 0.001 from our asymptote and sub that value into the function, I got a very, very large negative number. This tells us that when our x value is somewhere about here, our y value is really, really far down into the negative numbers, and this tells us that our graph goes in this direction. Now we move on to finding the x and y intercepts. In order to find the x-intercept, we need to set y to 0, and the first step I did was multiply each side by the denominator to get rid of the fraction. And I subtracted 2 from each side. Then I divided 5 in order to isolate the x, and got a x value of negative 2 over 5, or in decimal form is negative 0.4. Since we subbed in 0 as our y value, our point or x-intercept is negative 0.4 and 0. Now for the y-intercept, in order to find the y-intercept, we need to set x to 0. So I have my function, I set x to 0, and solved, and I got a y value of negative 2 over 21. Since we subbed in 0 as our x value, when x is 0, y is about negative 0.0952, which is our y-intercept. Now, we need to find our point of intersection. Since there is no linear oblique asymptote and the horizontal asymptote is y equals 0, there is no point of intersection since the function does not cross the vertical asymptote. So I have graphed my asymptotes, both vertical and horizontal asymptotes, labeled them, and plotted and labeled my x and y intercepts. Now, since earlier stated, we have ending behaviors here and here, and the graph needs to cross these 2 points. These are all indicators of how our graph is to be shaped. Same with these graphs here. Since we have a vertical asymptote here and an end behavior here, we know that the graph cannot cross, and we have a horizontal asymptote here. Now, sometimes graphs can cross them, but in this case, it does not. These are indicators that the graph goes like this. And same with this side. We have our horizontal asymptote here, and the graph does not cross. And we have our vertical asymptote here that the graph cannot cross. And now you have graphed this function.